Happy Friday, everyone. This is Brady Volpe, founder of the of the Volpe firm and Nimble This. We're back with Get Your Tech On, our show on all things DOCSIS. Today with us again is John Downey. John, thanks. Welcome to have you back. How you doing, John?
Thanks. It's always good to be back. Where's my tagline? Well, I'm not the prognosticator or procrastinator or the crystal ball.
No, I didn't get a tagline for you today. But, you've been traveling recently, right?
Yeah. I just got back from Atlanta, so I was at the Cisco SA facility in Lawrenceville, doing a little bit of DOCSIS 3.1 testing and prepping for SET Expo coming up in end of September, early October, New Orleans.
Yeah, it's amazing. Expo is upon us already. Last week I was at the Cable Labs Summer Conference, and it's actually the last summer conference that's going to be up in at 9,000 feet in this little town up there, Winter. It's where everyone goes skiing.
Keystone.
Keystone, yeah. Thanks for reminding me. The Summer Expo was quite nice. You've attended there before. I don't know if anyone's not attended Cable Labs Summer Expo or Summer Conference before. A lot of cable operators get together, vendors get together. Some of them have booths. There's a lot of information about basically where the industry is heading. What's going to be happening in the future is that Cable Labs is going to be moving their conference to basically off of the mountain at 11,000 feet, and they're going to be having it. It's not going to be a summer conference anymore. It's going to be called this Forefront. And basically, the first day will be for cable operator members only. The second day will be for a lot of other people to participate, but they're trying to bring in a lot more technology companies and decision makers to talk about basically, how technology is leading into the future. So you can go to this website, forefrontevent.com, and it'll tell you everything that's going to be going on. They're also moving it a little earlier in a year. I think it's June 23rd is the first day. So that's a change at Cable Labs. There was some other fun things that went on. If you saw the LinkedIn conversations, I did get a shirt. So on PNM, apparently if you talk to vendors enough and tell them that they need new things, new products in their technology, they'll and you really ride them hard enough, they'll eventually give you a shirt. So I figure if I'm going to keep doing this because I'll be in in shirts for the rest of my life then, because I can definitely complain and say, hey, you need this P&M feature and stuff like that in there long enough. So that was how I got the shirt. So there was a lot of discussion at Cable Labs about Cisco actually this year, John, and I kind of wanted to find out. There's also an announcement that Cisco is getting out of the FDX business for some time to come. And, so those kind of announcements were interesting. But there was also a lot of other talk at the Cable Labs Summer Conference just about what's changing in the cable industry for as far as virtualization and stuff like that. So, John, I know you're dialing back in. I was hoping to get sort of your feelings about where Cisco's heading, where the industry's heading, because of the changes that we see going on right now in the industry. So as soon as you get back on there, you can let us know. But after that, after coming back from Cable Labs, and as you said, we've got the Cable Tech Expo coming up. Cable Tech Expo is, I think that's in end of September, very last week in September. So you back with us yet, John? Dialing in? So I also opened up for questions in the Hangout channel for live events. So if anyone wants to ask questions while we're talking, please go ahead and drop that in the chat. And still waiting for John to dial his phone here. Other things that happened at Cable Labs that were interesting, again, everything's under NDA, so most of the things can't be discussed unless it was published. However, there we got John back. John, you there?
Yeah, we're just talking about me losing my connectivity, and
Yeah.
there it goes.
Let's fill in the gap. So Cisco, let's talk about Cisco. Those are the interesting things. You guys are getting out of FDX. There was a lot of talk about, maybe not even continuing to produce the CBR8. So what are you hearing, John? What are you seeing on your side?
I don't think it's a surprise that things are always moving more towards software. It's almost like the Microsoft model, right? It's easier to implement software and do things in software, cloud native. That's where things are going, further away from hardware. The hardware you can buy off the shelf. That's why you're looking at server farms and cloud native, where your CMTS code is software and it could be running on a server somewhere. And then everything PHY layer is simplified, and you just move that where you need it. That's why you do remote-phy, or in some cases remote-phy. But the software, and that's where things are kind of going. Now, the CBR8 is always going to be there. I mean, there's the direction is not on hardware. So as far as I know, the CBR8, I don't know that there's any more hardware plans for the CBR8. Like, there's no new line card being developed with different service groups, because the line card digital PIC, the physical interface card, we have a 100 gig card now that just came out. That would be more than enough capacity to feed a router, a switch, an optical splitter, to feed a bunch of RPDs out in the field. Your RF capacity in the QAM and OFDM, that capacity, the physical layer capacity, is out in the field. That's the RPD. So that hardware is being developed, and that will be there. We did a prototype, which we'll show at SCT Expo, which we showed at ONGA in June in Germany. I think it's kind of interesting. Instead of just it's part of the flexible MAC architecture, FMA, where it's not just remote-phy and it's not just remote MAC-phy, it's sort of remote CMTS, cloud CMTS, if you will. It's the cloud native processing MAC and phi all in one little component in the node. So you could cherry pick certain areas of your network that you need low latency, no need for timing, because it's all right there in the node. You don't need the PTP. Now, granted, if we do mobile backhaul, we're probably going to need PTP anyway. But for most systems that just need faster DOCSIS and lower latency, they're not doing mobile backhaul. The flexible MAC architecture and this remote cloud native idea, it might satisfy a lot of problems and satisfy the speeds that we need in certain areas. FDX, it's complexity, right? FDX, I've always said the limiting factor here is CPE, the customer premise equipment. Until I get a modem that has more upstream and downstream capacity and gets rid of the diplex filter and allows upstream and downstream to overlap each other, there's not a push for FDX. FDX satisfies the upstream problem. That's the whole point. So the question is, how bad is the upstream problem? Do I really need 500 megahertz of upstream spectrum to provide 1 gig upstream? I could probably do it with existing DOCSIS 3.1 spec and existing DOCSIS 3.1 modems. The spec says 204, 258 diplex filter, not really as a may or a must, but as a may. But there are modems that you can buy today that have 2 OFDM downstream, 2 OFDMA upstream, a 204, 258 split. With that type of upstream spectrum, you could offer a 1 gig service. You really could. This is assuming you're doing remote-phy. I mean, that's the first step, right? You got to go digital fiber. You can't be doing this with analog fiber. So I think you don't deploy technology for the sake of technology. You deploy what makes sense, and FDX looks great on paper, looks great for urban areas, but not suburban areas. Suburban.
Suburban.
Yeah. Because if you do out in where I'm living, crap, man, at 1 mile, you're only hitting 20 houses.
Dude, it would be just good if you had
you can't do node
cable
0.0
in your area.
Yeah.
So, well, yeah, I mean, and
you know
that's
what it is? It's like raw.
yeah. No, so I was going to say,
Good.
I mean, some of what we heard that we've heard recently from operators is not everyone's looking at going to Node plus zero. So I think that makes a really big challenge for FDX if you're not going to go to Node plus zero, because you pretty much need Node plus zero for FDX.
Yeah, I mean, there was talk about, John Chapman talked about a node plus one or plus two, where we develop an amplifier with echo cancellation on the front and
That's
back
the
end of
FDX
the
node,
amplifier.
right?
You know, well, FDX amp. So
yeah, I'm sorry, FDX
so we have
amp. Yeah,
we have the FDX node. Yeah. So you would have to develop that amplifier, and that's John's way of trying to get the industry behind it to say, all right, someone step up to the plate, say, yeah, it's a good idea, and we'll develop it. Well, Cisco's getting out of hardware. So we're not going to develop
we have a concept of the FDX amp, but has anyone actually designed one and proved that it works?
I think it will. I think that you could. I don't think it'd be hard to prove it works. I think it would be someone has to do the market study to say supply and demand. If there's enough demand, someone's going to supply it at a good price. Now, I think what's going to come down to is if I put echo cancellation inside of an amplifier, one, what does it cost? That's number one. Two, what is the power draw? There is a big concern about how much power these devices take. I didn't really put one and one together and make two in some regards. Like when you look at actual power of a node versus a line extender, the nodes are supposed to be under 160 watts. The amplifiers could be 30, 40 watts. If you do node plus zero and you get rid of all your amplifiers, but you have to put in more nodes, you could end up with a lot more power requirements than if you did node plus three. You understand what I'm saying? Because every node you put in and you replace 3 or 4 amplifiers, that node is worth 3 or 4 amplifiers of power draw.
Yeah, and we've seen that when
you really have to draw it out and then add it all up.
Yeah, and in areas where they put in node plus zero, it's a challenge. It's a challenge powering all those nodes because you can reuse some of your old power supplies, but you ultimately end up needing to add more power supplies because the nodes draw so much power.
Yeah, and they're farther apart, and if you had existing coax that you're not using, you could use it just for the power distribution. You could figure out how to centralize your power supply and still use it. But I mean, yeah, there's a lot of stuff going on there. There's still a push in the industry for the new marketing is 10G, right? 10 gigabit per second offering, and I think the push will be 204 megahertz upstream. ESD is the new word for extended spectrum DOCSIS. 1.8 gigahertz, maybe up to 3 gigahertz. Obviously, when you go higher frequency, there's more loss in coax, but we're assuming we're getting less and less coax. Yeah. That's sort of the assumption, right? You're going fiber as deep as you can. The coax is dropping less and less and less. And you could, if you run the numbers, it'll be interesting to see. I was a little nervous on the 204 upstream levels, but I think if we, with the added power of DOCSIS 3.0 modems, I think we can make it work without the need for upstream AGC, which is one of the concerns I have because you don't have AGC on the upstream. You're going to rely on the modems to provide an automatic gain control.
Yeah. So, John, that was actually, you did a remarkable job there of turning my original question into a technical discussion. But I want to summarize. So basically, you guys, you will be not doing anything in FDX for some time, which is what the technical article, the article from BTR said. But the CBR8 still has plenty of leg room out there because it just fundamentally has the capacity to keep going with DOCSIS 3.1 and fiber nodes and stuff. Is that a good summary?
Yes. You said earlier, we were talking how I heard that the CBR8 is going to be shelved. I'm like, that was a play on words. We are doing more shelves. It has nothing to do with shelving the CBR8. So we have the remote-phy shelf, which is a 1RU compact shelf. And then we have this new HA shelf. It's the SmartPHY 7200. We're resurrecting the 7200 word. And what it meant was 72 service groups. But the HA shelf that we have is a remote-phy shelf that would work well for condensing a hub site.
Yeah.
Like maybe you have, you buy a mom pa cable company and they have their own head end or hub site. You're like, you know what? I have a centralized head end with all this content. I can just run the digital fiber out there and really just displace all your real estate and put in a remote-phy shelf and run all the smarts from my centrally located CMTS. So and then that shelf can still feed your analog if you really want to. You know. But so we have an HA shelf, we have a compact shelf, which is good for MDUs. You can rack and stack shelves, and then we have the regular RPD that remote-phy device that will go in the node. So that hardware is still there. We're still in the optical side, but I believe Cisco is not going anywhere. We sold the CPE to Technicolor. We sold the video product off. I was surprised we kept taps and amps for as long as we did. And as far as I know, we're getting out of that hardware side of it as well. So it's the CBR8 is still there. The shelves are still there. It's more software driven. CBR8, it's a product I do like. I mean, I wish, to be perfectly honest, I wish the CBR8 would have came out before we had to do the 10K with modular CMTS.
Yeah.
We went modular to integrated, and now with remote-phy, we're going modular again.
Yeah. All right, so let's get on to our topic for today, which is DOCSIS 3.1 Upstream, which I understand you've been doing a lot of testing with.
Yeah. There wasn't a big push for 3.1 Upstream. We got a lot of best practices and feedback on DOCSIS 3.1 downstream because people were doing it and they've been doing it, and it was mostly because of spectrum.
Well, and the big demands on a downstream. So everyone says, I need more bandwidth on a downstream. It's really the upstream has been the lagger, but I think now we are starting to see a demand, a requirement for more bandwidth in the upstream. A lot of people doing YouTube, gaming, streaming their YouTube in the upstream. So it is driving a need for more capacity in the upstream.
Now, are you seeing people doing how do I want to say it? Actually sending video on the upstream? Is that what you're seeing or what you're saying? YouTube on the downstream and Netflix on the downstream, adaptive bitrate over the top video does create more upstream acknowledgements, but I'm still wondering, what is the killer app on the upstream? Is it home security? Is it Slingbox? Is it some type of video on the upstream? Or, I still don't know what the big killer app is.
So I don't know that these are killer apps, but there's a lot of YouTube content creators. I mean, like right now we're streaming about 50 megabits per second in the upstream as we're doing 46.9 megabits in the upstream. That's what I'm sending right now to YouTube as we create this content. Whenever the other thing that's so that any YouTube creator that's creating like what we're doing right now, you need about a 50 meg upstream if you want to do HD. The other thing that's real common is gamers. So the article that's coming out in Broadband Library in just a couple, a week or two, talks about the gaming industry. And this was also something that was talked a lot about at Cable Labs Summer Conference. It is a multi-billion-dollar industry. A lot of the gamers make money by streaming their games. So what they're not only playing a game, which is driving a little bit of traffic, but the actual big traffic is when they're doing a YouTube stream, live stream of their video that they send either to YouTube or to a Twitch network, which it's another streaming network where people watch these games. And so every one of those streams is a significant amount of upstream data, depending on what definition they're sending that data.
It is kind of ironic, isn't it? People don't just like to play games; they like to watch other people play games.
Yeah, and it's a few weeks ago there was the Fortnite championship, and I mean there was one kid won $3 million just for being really good at Fortnite.
Yeah.
So there's money in this stuff.
All that. Now all these kids think they can make money. It's one kid out of a million, or 100 million.
Yeah.
Just let's not get ahead of ourselves.
But there's still money there. So,
No
so now that's
Yeah,
why
yeah, I
people
agree.
operators looking at using OFDMA in the upstream to increase that capacity, and I think it's so what are those challenges? Is it just as easy as turning it on and all the modems work? So I think those are what operators are starting looking at right now.
One of the things that's pushing OFDMA and DOCSIS and upstream is 85 megahertz upstream. You're adding more spectrum. If it's 42 megahertz, you're already limited. I'm going to be a firm dissident and not a proponent of PAFDM. So time and frequency division multiplexing, you could have 3.1 modems starving out your 3.0 modems if you're trying to share time. Anytime you have a 3.1 transmitting and then a 3.0 back and forth, you have to create guard time and on the wire to switch between the two, and it's not going to be as efficient as you would hope.
Yeah, so
I would
we
really
talked about
rather
that.
promote.
We talked about that coexistence for a long time, where it was just going to be seamless, like magic, where they can both live together. So what are you seeing? You're saying the 3.1s will take up more traffic? Is it because of overhead, or is it because 3.1 are just dominating the channel?
I mean, it would come down to also code, how you code your scheduler, but it would also come down to how many devices out in the field, right? There'll be an inflection point where the 2.0, 3.0 starts going through attrition, and there's more 3.1 devices being deployed. I would rather see customers allocate spectrum for 3.1 and 3.0, just like we do downstream, but that also comes at a price of spectrum. And then you had to question how many devices are going to use that spectrum, like how many devices are actually out there. 3.1 obviously is more efficient. You have more modulation to work with, more modulation profiles. Signal carrier QAM, ATDMA, 64 QAM is the most we can do, but 3.1 we can go all the way to 4K QAM. Now, is that a pipe dream? Yeah, in some cases it is, but if I do remote-phy, I get rid of the analog link. I don't have laser clipping anymore in the upstream. I have much better MER. Now, granted, I could have a 35, 36, 38 dB upstream MER, and I could get away with 1K QAM on the upstream, not 64. So it's more efficient. I get more speed. With an 85 megahertz upstream, we foresee customers sticking with 4 ATDMA below 40 megahertz, and then from 40 to 85 doing OFDMA. But then that means you're going to 85 megahertz. What we're seeing with some customers is it's not the amount of modems in the field that have filters already in the modem. What about the houses that have house amps that cut off at 42? They could be active downstream and passive upstream, but they basically have diplex filters in them.
Yeah, and so I've seen a lot of that.
Where I'm going with that?
I've seen a lot of that with the house amps. So I work with some systems that are 85 megahertz, and they really don't know which house amps are going to be there. Right now, they're doing only ATDMA, but they're doing SC QAM in the upstream, but they're doing 8 SC QAM channels, and so they're trying to balance that where they have different service groups, and they have like a 4-channel bonding group in the upstream, an 8-channel bonding group. So the houses that have only that have the house amps in them. So you have that house amp has a 42 megahertz diplex filter, even though they have an 85 megahertz return. So the modems that are behind that house amp can only bond to 4 channels rather than 8 channels, and then it's sort of like a partial mode sometimes that the modems run into if they don't lock on to the 4-channel bonding group in the upstream. So that is it's a challenge. It's interesting because it's not something you really I had not thought about before until I actually started seeing the modems in partial mode behind the house amp.
Well, you think about it, a 42 megahertz filter house amp, it's not a brick wall filter. It's going to have a roll-off. You're almost better off, because the 2.0 modems are kind of dumb, right? I mean, they lock on downstream, they get UCD for upstream channel descriptor, and they might try to range on an upstream at, say, 44 megahertz, even though the built-in modem's diplex is 42. So you're better off even putting a single carrier QAM, say, between 40 and maybe 50. You could put 4 6.4 megahertz wide channels from 50 to 85, from 55 to 85.
Yeah, and
so you could make your own little no man's land between 40 and, say, 50 something.
Yeah, and that's the issue we're seeing right now, where they have 8 SC QAM channels stacked back to back. When you look at it in a PNM application, you see that fifth channel right around, above 42 megahertz, right in that area. A lot of the times the modems are able to lock onto that fifth channel because of pre-EQ. They have the transmit power jacked way, way up in order to lock onto it. But you also get a large number of uncorrectable code word errors on that fifth channel because it is in partial mode. It's not dropped off. It's still locked onto there, or it's not partial. It's impaired mode because you're still transmitting data over it, but you're getting very high uncorrectable code word errors on that channel. So it's in that case, like pre-EQ is doing too good. So.
Yeah, I mean, you could have a 2.0 modem lock on that fifth upstream, and you don't want it to. You could have a 3.0 modem lock onto it, and because of how you made your upstream bonding groups, it might say, "Oh, I'm on this upstream 4, which is the fifth upstream, and because that is part of this 4-channel bonding group above 42, let me try to bond on these other upstreams I have no chance of even seeing." So it goes into basically single-channel bonding.
So how big of a space
really
should you
want to relegate that device to the first 4?
How big of a space should you allow between the
I'm thinking 40
ATDMAs? Go ahead.
Well, when you think about it, if you're afraid 85 megahertz is going to have some roll-off at 85, you might say, well, my 6.4, the highest I want to go is, say, 82, 83. You take 4 of those ATDMAs times 6.4 times 4 is 25.6. So 83 minus 26 puts me where? 50-something? 54, whatever it is.
Yeah.
You understand what I'm saying? You can still easily fit 4 ATDMAs butted against each other at 52, 53, and still be under 85.
Mm-hmm. No, but you have to.
So
your 4 ATDMAs you want to keep below.
50.
You want to keep below that 42 megahertz cutoff because of the house amps.
Correct. So you have 4 below and 4 above.
Right.
Then 4 above, you're still giving yourself a little bit of buffer space from 40 to, say, 50.
Right.
And that might be enough, 40 to 50. Just don't put a single carrier quant between 40 and 50.
Yeah. All right. So what else have you learned from
your... So the question is, so the question would be is at what point do you just get rid of all the ATDMA above 40 and just make that OFDMA?
Yeah. And then no longer
that will come down to how many 3.1 devices. How many 3.1 devices in the field to take advantage of it. That's what it comes down to. So if I am doing higher downstream speeds, then obviously I have 3.1 devices already out in the field. Then it's a good idea to maybe convert them to 3.1 upstream as well. If you're offering 1 gig down, you're probably selling that with a 40 or 50 meg up. It would be better to push them to 3.1 spectrum on the upstream, and that will help alleviate them eating up the 3.0 spectrum and the 3.0 single carrier qualms that other devices have to use, which is the 2.0 modems and the other 3.0 modems that have maybe lower speed, 10 megabit per second.
Yeah. And I'm getting more and more operators asking for 100 megabit upstream tiers, which that sounds like the sweet spot for 3.1 modems with their own OFDM channel. How many 3.1 modems would you put on a 100 meg upstream tier? If we're using that OFDM channel above 42 to 85 megahertz.
So OFDMA, you keep saying OFDM.
Sorry, yeah.
So if so 40 to 85, if we're doing an OFDMA from 40 to 85, and we can get away with 1K QAM, I think we estimate that could be worth like 300 megabit per second, maybe more. And you're offering 100 meg service, so your pipe is 3x of what you're offering. So obviously 3 people can use that pipe at the same instant in time.
Full time. You do.
And because it's so big, stat muxing could be 20 to 1. Maybe I wouldn't push it that far. Maybe I'd say 10 to 1. So 3 times 10 is 30 customers
subs.
Could have 100 meg service.
Yep.
Yeah.
Which is pretty realistic off of
and that's not unrealistic, right?
Yeah, that's very realistic because you're probably not going to have
the upstream. Yeah.
You won't
200
have
customers in the service group. So
very,
30
very
of them.
Realistic. If you got that many doing 100 megs, you're going to be selling a pretty good service, 100 megs on the upstream. So that's very good.
Yeah, it's a good problem to have, right? It's a good problem to have. You're selling a higher service tier, usually at a higher price. You would hope so, right?
Yeah, definitely.
So this is one of the things we're addressing now is the realistic nature of HFC plants, house amps, how to identify where these house amps are. The modems report their capability, and we can tag off of TLVs and other stuff like that, and we have SNMP capability to the modem. So we can see which modems have built-in filters. The problem we're also seeing, though, is some modems have capability reporting of 85, but their own internal filter might be 42. And maybe they're not reporting the filter, they're reporting the chipset. So the chipset might be 85, but the actual filter is 42. And those devices are hardware filters. They're not software controlled. Now, with the 3.1 modem, a lot of times there's software control to change the filter via software. The 3.0 modems, typically it's a hardware device. You bought that modem with a 42 filter.
Yep.
You're not just going to sit there and let's change it to 85 on the fly, because it might not work.
Yeah, you're stuck with that.
Yeah. So that's one of the things we're dealing with. And then the house amps, obviously, is another issue. So that's one aspect of this whole, how do I plan for 3.1? Well, spectrum is one of the first things. RF is one of the first, physical layer, right? The other thing I'm finding out is, does upstream impairments look the same as downstream? For instance, that, and we've gone through this before, a correctable effect on the downstream is not something we should be tracking anymore for OFDM, because you could have 100% uncorrectable or 100% correctable effect, but there's really no problems. One, it's corrected. Two, how we do FFT of this entire 192 megahertz OFDMA downstream channel, and the LTPC, the time and frequency interleaving, all these things we're doing in this mathematics that we could have one bit in error, but it's showing up as 100% correctable effect.
Yep.
So I know Ron Rack has written some stuff about it. So then I went back to, well, do you think we might have something different on the upstream? Because the upstream is bursty and it comes in chunks of mini slots and frames, and then we do this averaging of MER within a frame or mini slot, I don't think we're going to have the same type of response on the upstream, meaning we're not going to see 100% correctable effect on the upstream. But I would still have a word of caution to say I wouldn't use correctable effect as an indicator of plant health for OFDM and OFDMA. I would still rely on MER and uncorrectable effect. Uncorrectable effect is drop packet. That's the bottom line. So I'm looking at uncorrectable effect and MER. Correctable effect is still something I don't think is a good indicator of plant health, because OFDMA upstream and OFDM downstream is different than single carrier QAM. Mm-hmm. Also, I looked at ingress cancellation. Now, ingress cancellation, from the Broadcom upstream chip perspective, schedules many slots of time to measure the noise floor. Well, that's great for a single carrier QAM, but for OFDMA, it's subcarriers. So it's a little bit different than single carrier QAM, meaning that if I have an impulse noise event, or not even impulse noise, let's just say it's CB radio at 27 megahertz, or some type of narrow steady state ingress that's only 100 kilohertz wide. Well, how many subcarriers are actually going to take out? Well, if the subcarriers are 25 kilohertz, you're really only taking out 4 subcarriers.
It's 50, you're taking out 2.
It's not like you're taking out the entire channel. Like single carrier QAM, it would knock out the entire channel, yep, even if you only knocked out a little portion of it. But for OFDMA, you're only knocking out a couple subcarriers, which it's not that big of a deal. So there really isn't the same concept of ingress cancellation for OFDMA. But with that in mind, I'm also feeling that when you decide to do upstream profile management, where we call it IUC, Interval Usage Code, where I go from, say, 1K QAM back down to 64 QAM, should I ignore a certain percentage of subcarriers? For Cisco, today, we ignore 0%. I'm kind of leaning towards maybe we should ignore 1%. That way, real narrow ingress knocks out one or two subcarriers. I'm not changing modulation just because that one event or just that small portion of subcarriers is affected.
So
Does that make sense?
It does, but you just hit on something that I want to come back to, because you said when we decide to do profile management in the upstream. Right now we have multiple profiles that we send to modems. So, 4096 QAM if there's no impairments, and then if there are some impairments, it might be 1024 QAM or 512 QAM. They can drop down to use lower order modulations in the downstream. I just had a conversation yesterday in the upstream when we were talking about OFDMA, and there was some question as to whether or not vendors are using more than one profile in the upstream. So I kind of wanted to ask you that, because she said when we decide to start using different profiles in the upstream. So are we stuck to one profile right now in the upstream for OFDMA?
No. What I think we're stuck with is it could be a modem issue, it could be a CMTS code issue. Is we're seeing two IUCs or two modulations possible, and the modem at this time is using IC13 as a registration IUC,
which is QPSK.
And that's usually going to be lower, like 64 QAM. No. It's usually 64 QAM. So IUC
for registration
is yeah. Now you might be talking about the initial ranging.
Initial ranging is QPSK.
Initial ranging.
Yeah, because we just went through this yesterday.
Yeah, you might be thinking initial ranging because you have pilots, you have fine ranging, initial ranging, you have boosted pilots, you have probes, but I'm talking about the actual IUCs used for the data traffic.
Okay.
Once the modem is online and sending traffic, it might be using IUC13, which could be 64 QAM. We might set it even lower, set it 16 QAM.
Yeah.
And once the upstream MERs, now the upstream MERs are at the CMTS, so we don't have to probe the modem. We just have to talk to the CMTS. The CMTS is already there. Everything's coming back on the upstream. We look at the CMTS, we look at the upstream MER readings for all the subcarriers and say, all right, you've exceeded certain thresholds for certain modulation, so you are a good candidate for this next IUC that the user configured. Maybe IUC 11 was 512 QAM or 1K QAM. So the CMTS can make the decision, yeah, you're a good candidate, so yeah, move up to a different IUC.
But is this like dynamic modulation profiles where you can bounce up and down depending on the SNR or correctables and uncorrectables? Correct.
But dynamic modulation usually is on a per upstream basis, so it affects everybody. Here you're talking about individual modems.
Mm-hmm. Okay.
So don't think about the noise funneling effect. Think about modems having group delay, micro reflections, individual problems, individual modem problems. Yeah, it's a little bit different on upstream, right? Like downstream, you could definitely have different MER.
Oh yeah.
You know what I'm saying? On downstream, but upstream, everything funnels back. So everyone usually has the same carrier to noise ratio, but not necessarily the same MER. Do you understand where I'm going with that?
Yeah, absolutely.
Yeah, so I mean, carrier noise ratio is just noise funneling, and everyone has it's hitting the CMT usually at 0. So you all have the same noise floor. You don't all have the same MER.
Nope.
Because MER is indicative of group delay, micro reflections, some things pre-EQ will take care of, but it might not be perfect. So individual modems are different distances away. They incur different micro reflections, different cabling issues.
In-home
so
wiring
every time
is
they
different
transmit, they might have different. Yes,
Yep.
Exactly. So it's not really an ingress problem. It's a timing or a group delay or something of that nature. So that one modem could have bad MER, and maybe it's only a portion of its upstream spectrum. Well, the CMTS might say, well, you've exceeded this threshold for IUC 11, so you can't do 1K anymore. But looking at your MER readings, I see that maybe you can do IUC 12, which was 2 QAM. Well, now you're actually lower, so I'm going to drop you down to basically the maintenance IUC, which is 13, and I'm relegating you back to 64 QAM. And now I see you're even lower, and I'm getting a lot of uncorrectable fat, so I'm going to mark you as partial. So now I'm not even going to let you send traffic on that OFDMA anymore. I'm going to maybe push you back to your single carrier QAM. Because a lot of times we're recommending that when you do an upstream bonding group, you actually bond with a single carrier QAM and the OFDMA. You don't just do OFDMA by itself.
And that's on a per modem basis.
Yes. Okay. And it's the same thing for downstream, right?
Yep.
Yeah, downstream is at a per modem basis as well.
Yeah. Well, I mean, I thought the downstream wasn't as granular. I thought the downstream, you grouped the modems. You clustered the modems.
No.
Okay.
The modems are individual modem basis. I mean, one modem could be doing 4K QAM, another modem might be doing 2K QAM. Now, the modems, they hold on to 5, what do you want to call it, profiles? Mm-hmm. 5, what's the word for it? I guess you could say profiles.
Yeah.
It's mod profiles, downstream mod profiles, and 0 is your data profile. And all the modems register on profile 0. Then once they start reporting downstream MER, then the CMTS can upgrade them to one of the other 4 profiles that he uploaded during registration. And one could be 4K QAM, 2K QAM, 1K QAM. You might have a mixed profile for downstream. So that's how the downstream works. But that's on an individual downstream basis, individual modem basis. It's not in groups.
Okay. I stand corrected.
Understand?
Yep.
Good?
I do.
I stand correctly.
Roger.
Clearance plans. Other stuff, I mean, so that's, the more experience we get, obviously we'll come up with more best practices. You have to have some practice to have a best practice. But there's not a lot of people deploying yet because the demand is not really there. It could be spectrum's not there. And even if spectrum's there, it might not be the demand for upstream. You mentioned 50 meg service. I don't see a lot of people offering 50 meg service. It's like 30 meg, it's 20 meg, 10 meg. Until we start offering 50 to 100 meg, maybe there's no demand for OFDMA yet. But it is there. It's in the CPE, so the modems have the capability. The CMTS has the capability. It's a matter of having the spectrum to allocate for it and utilize it properly. So it is pretty robust. It will, it's just like the downstream OFDM compared to single carrier QAM, it's more robust. Everyone is more robust. The spec and the technology is more robust than DOCSIS 2.0 and 3.0. So it's no reason why we shouldn't be using it and utilizing it.
So have you seen, I mean, do you have good data on like what the minimum MER is to support 1K QAM in the upstream, 512 QAM, etc.? Do you have good data on that? Because I know like originally in a downstream, we thought we needed some number and we actually did better for MER than what we needed. Are you seeing the same in the upstream?
Yeah, it's interesting because I thought the same thing. Is the table that the 3.1 spec has in the spec itself, Cable Labs, look at the Cable Labs spec for DOCSIS 3.1, there's a table, table 7.1 or whatever that table is, and it lists the different modulation and the different breakpoints of MER. And we know with the technology, with forward error correction and low density parity check and time and frequency interleaving, that it's probably about 6 dB conservative. So in the CMTS, we can have offsets to that table. Because in our CMTS, we use that table as the default breakpoints. And what we know from best practices and actual experience, that it's about 6 dB more conservative than it needs to be. So I'm like, well, what are we doing in the upstream? Well, it turns out we're using the same exact table. The same breakpoints were specified even on the upstream.
So you just calibrate it to that table, your CMTS.
Yeah, basically, I know from experience that single carrier QAM, ATDMA, 64 QAM will break under added white Gaussian noise, meaning uncorrectable effects are incrementing about a 23 dB MER. So I always set my breakpoint for 24 dB, so I give myself 1 dB headroom, and then I usually have dynamic modulation based on that 24 dB MER and 1% uncorrectable effect. So I do a logical end function. So even if MER is cosmetically wrong, I'm still looking at uncorrectable effect anyway before I make any decision. That's for single carrier QAM.
And Reed-Solomon.
Because of OFDMA, yeah, correct. So because OFDMA is more robust than the single carrier QAM because of the technology, I don't know that 23 dB would be the breakpoint. The question would be, is it 6 dB better? Is it 18? Is it 19? Is it 20? That I don't know yet. And you can't make a blanket statement if you're just saying additive like Gaussian noise, because what about group delay? What about microreflections? What about impulse noise? So there's a lot of different variables that would need to be vetted out to say, all right, what's realistic? Now you might say, all right, if I baseline it, the breakpoint could be under 20 dB, so be it. But I would still want any decisions made on uncorrectable FEC.
Yeah, and I think in the upstream we have a lot more impairments than what a lot different type of impairments than what we typically see in the downstream, like impulse noise or some of the different things that we typically wouldn't see as much in a downstream. The upstream's so much more challenging of an environment.
Yeah, and then that it takes one customer, right, with ingress to knock everybody else out. It's that noise funneling effect. The other thing that I was curious about is there's something called boosted pilots on the upstream, and I was confused that I thought the pilots were like this fine ranging where the pilots were dictating the level at different frequencies. On the OFDMA upstream, you can actually specify the initial ranging frequency. By default, Cisco sets the initial ranging at 1/3 up from the lower band edge. So if I'm doing 40 to 85, 1/3 up would put me at 45, 1/3, 15, at 55 megahertz. So the initial ranging would be at 55 megahertz. But you have the capability to set where you want that initial ranging to happen. And you might want it lower or you might want it higher. If you put it higher, you realize there's going to be more attenuation in the cable plant, but maybe that's a good thing. Maybe that does worst case ranging and power level. Maybe it's a bad thing. Maybe you have roll off and it's not a good thing. So you might look at that different, like kind of philosophically, what is best? Do I do initial ranging at the lower end, the middle, or the upper end? So you have that capability to make that decision. For instance, we talked about the in-house amplifier 42 megahertz problem. If I do 40 to 85 megahertz OFDMA, maybe I should do the initial ranging all the way up at 65. That way, if there's a 42 megahertz filter in the house, I actually fail. Because you don't want the 3.1 modem to register. What's funny about that is we're finding that the initial ranging is QPSK, I think it's QPSK, and it's so robust, it might still actually register even with the 42 megahertz filter in the house. It's almost like it's too good.
Yeah.
So we're still experimenting a little bit with that scenario of what should we do in this scenario? How do we identify a house with a 42 filter and it's a 3.1 modem in the house? How do I identify where to send an RF tech to change it out? Like you might say, well, when they put the 3.1 modem in the house, didn't the tech check? Well, this is a case where the customer signed up for higher speed and you mailed him a 3.1 modem. So he did his own upgrade. He had a 3.0 modem. He upgraded to 3.1. The tech never came out. The customer just plugs in the 3.1 modem, apples to apples, change cables, whatever. But now all of a sudden it doesn't work, or it doesn't work properly. Right. So we need to figure out how to identify those houses to then deploy the technician to fix or get rid of the filters.
P&M.
Yeah, P&M. It is. It's P&M. I mean, if you could do full bandwidth capture, and we can find the upstream spectrum also as part of full bandwidth capture, that would show us right away, right?
Yeah, it's actually something that we've been looking at doing with one of our customers. So to identify where that roll-off is and the bandwidth throughout the network. So it's actually something I think we can do with full band capture. Lets you see where it rolls off.
Yeah, because even if you don't have carriers there, the filter would affect the noise floor as well, right? Normally you have some noise you could probably see the response with the filter.
Yep, you can tell with the noise floor.
And I think don't the 3.1 modems, you could also tell the 3.1 modem to send like a sweeping type of carrier on the upstream?
Yeah, Yeah, and
I
that's
remember we
something
did
they're
this
just
with
doing
another
in
cable lab
the
interrupt.
not even with 3.1 modems, but you can do it with 3.0 modems, and it's something that doing as part of the SCTE Working Group 7 on how to do sweepless sweep with full band
Mm-hmm.
captures. So it is amazing technology you can do with P&M, just even with 3.0 modems. Things like sweepless sweep, both in a forward and
But sweep,
return, so you don't
yeah,
have to
sweepless sweep
do...
would be like a, yeah, sweep. Yeah, the sweepless sweep would be like a downstream, just comparing, right, and using existing carriers. But I'm thinking on the upstream, I believe you can tell the modem
You can
to
yeah. Well, there's a couple of
send
different
a
things you could do.
sweeping signal through the spectrum.
If you have a bunch of SC quams, you can just look at the in-channel frequency response
Of
across,
course.
and you basically have a swept spectrum response. Another thing, something that technology that Cable Labs developed is you can take a modem, like a test modem, and scan it through the band, and you'll get a complete sweep of that modem scanning through the band in the upstream. So there's a lot of technologies that have been developed, especially for remote-phy deployments, that basically eliminates the need for doing an invasive sweep. It's all passive sweep, so you don't have to add that capability or technologies into remote-phy devices. Can all be done with DOCSIS.
Because couldn't you have a 3.0 modem that's successfully locked on the bottom 4 ATDMA channels, and then tell that modem to sweep all 85 megahertz?
Yep.
Because you have to have it online and registered first before you do any SNMP to it. So you have to be registered and online. But how do we? Let's say it's online below 42 megahertz. How do I test above 42? I should be able to tell that modem to generate a sweeping signal all the way through. He's not doing 8 single carrier qualms because he never could.
Correct.
But he's locked on successfully at 4 single carrier qualms below 42 megahertz. And I should be able to tell him, hey, send me a signal to 85. And then when I see the response, then I can say, oh, yeah, he either has his own filter.
Yeah, there's a home amp.
There's a house amp with
There's
a
a
filter.
house amp. Yeah. And I did want to mention, because Brian Wilson brought this up a little while ago in a chat room, for people who do have 3.0 modems with a diplex filter in them, he indicated that sometimes you just need to upgrade the firmware in those modems in order to get that diplex filter switching to higher frequencies. So that's for people who do have 3.0 modems that does have a switchable diplex filter. Upgrade your firmware if it's not working properly. So thanks, Brian, for that tip.
So I mean that's and that's assuming it is a software changeable filter.
Yep.
So the other thing I deal with is back to the boosted pilots. I was concerned, if you look at the spec, it's basically 10 times the log of 3. It's 4.7 dB boosted. So it gives you better response on these pilots, but the pilots are not used for levels, they're used for synchronization. So if you do boosted pilots, you don't have to do as many pilots because you're pretty sure the boosted pilot will get you synchronization more efficiently. So by doing less pilots, you have less overhead. So you get a little bit more speed. The question is, does that 4.7 dB boost in the pilot level, does it affect my levels, my transmit levels, my receive levels? And it doesn't. So that's kind of the good thing. I was a little concerned that if I did this boosted pilot idea, if it would affect my own transmit levels, and it doesn't. So that's kind of satisfied my curiosity on that one. Because I'm always concerned about how do 3.1 modems actually register, what levels are reported. I told you this before. If you take a 3.0 modem, remove it, put a 3.1 modem in its place, the transmit level will show 6 dB less. Do you remember why I said that?
60.
Say you have an existing location, 6 dB less.
It's 8 carriers or 4 carriers?
No. It's single carrier QAM, 6.4 megahertz. You take the 3.0 modem out, and you put a 3.1 modem in, and you're still doing the same ATDMA channels. The transmit level is all based on, you look at transmit level between 0, 1, 2, 3. We always report the transmit level of each individual channel. But the modem will report 6 dB less.
Is this because of the, so it's the total power over the spectrum?
No.
I don't remember, John.
It's still doing DOCSIS 3.0. It's still DOCSIS 3.0 upstream, but the 3.1 modem. According to the 3.1 spec, if you have a 3.1 CMTS and a 3.1 modem, even if you're doing 3.0 upstream, the modem has to report in 1.6 equivalent power. So take 6.4, divide by 1.6, it's really 10 times the log of 4. That's 6 dB.
Okay.
So if you replace a 3.0 modem with a 3.1 modem, you might see all your transmit levels drop by 6 dB, and then you're like scratching your head saying, what the heck's going on? Nothing has changed in the attenuation path, but the reporting is different. So just keep that in mind. It's something to keep an eye on. It's just a reporting difference. It's still the same power.
I was going to say, the actual power is the same, though,
came
right?
out with the command. Yes, exactly. It's just reporting based on 1.6.
Right.
So just add 6 dB to the existing power level, and you're right back to where you were.
Yeah, modem's transmitting the same power as the 3.0 modem. Receive at the CMTS is the same. SNR, MER should all be the same. It's just what the modem is reporting via SNMP to your monitoring system.
Correct. Even on our CMTS, we came up with another command that says Showcam Modem Phi, PHY. We do a Showcam Modem Phi norm for normalized, and then we actually normalize the power level based on the actual channel width.
Yeah, I'm glad you said.
Add the 6 dB back in for you.
Glad you said PHY. I kept thinking you were saying FY. So Phi.
Yeah, Phi for PHY. Yeah. So Showcam Modem PHY is the command you do to see modem transmit levels. So if you do that Showcam modem for the cable interface, you put PHY at the end, it'll show you the modem transmit levels, the downstream levels, assuming remote query is on. It'll show you upstream level, receive and transmit, upstream MER. There's a lot of stuff in that command.
Okay.
And I'm sure Eris, CommScope, they probably have the same command as well.
Yep. Eris CommScope. That name's just taken me a while to get used to. I still always use Eris. So, all right, John, we're at the top of the hour. Is there anything else you want to go over? Or we covered it all?
No, I just covered enough anyway for now. But a plug for SET Expo. I know people going out to New Orleans, September 30th, October 1st, 2nd, 3rd, whatever it is.
Yep.
I'll be moderating a panel, a couple guys from CommScope, on the road to 10G. So that should be actually pretty good. Talk about FTX, talk about extended spectrum DOCSIS, some ideas on how to get faster upstream speed, what type of speeds we're looking at. So I think it's good for the industry. We still have a lot of legs underneath of us. And the fact that we renamed FDX DOCSIS 4.0 now, right?
That's right. We didn't mention that, and I've been meaning to do that. We now have DOCSIS 4.0 specifications, which I think is rightly so. They've taken all the 4.x out of DOCSIS 3.1 specifications and put that, the FDX out of 3.1 specifications and put that into the DOCSIS 4.0 specifications. Those have all been released. So lots of great reading for everyone out there who wants to download those and cures insomnia and everything else. So good reading for everyone. And for SCT Expo, it's amazing. This year is going by so quick. We're already in August. SCT Expo is coming up. We will be back. I think we have a show between now and Expo. We're going to have PPC on to talk about some connectors and connector issues and stuff like that. So we'll have them on between now and then. And other than that, I think that's all. It's a wrap. So, John, thanks for your time. Thanks, everyone, for watching. Please do hit subscribe. If you watch us on YouTube, hit the bell so you get notified when we upload new videos or do live podcasts. And if you will listen to us on podcasts, please hit subscribe on your podcast catcher so you catch all of our shows. So everyone, so long. Catch John and I at SCTE Expo. If you're there, we'll do something funny. So everyone, take care and bye-bye.
All right, we'll see you. Good discussion.